Hi, welcome to Space Learner Academy. This is Mr. Colossa, and today I have decided to do some revision for exams. And please note that this is the electric circuits video. It is for grade 11 and grade 10 students, but a grade 12 learner can watch this video only if they do not understand electric circuits at all. So this is the perfect video for someone who wants to practice electric circuits, who is doing grade 10, grade 11, and grade 12. However, note that if you are doing grade 12, the part for EMF, the part for EMF on this type of circuits is not included, since this is for grade 11 and grade 10 electric circuits. So, however, if you're doing grade 12 and you have no idea on how to answer questions related to electric circuits and you would like to understand how electric circuits work, then you can watch this video because it's the basics of electric circuits. Okay, so this is video number 1. I'll keep on posting video number 2 and other videos related to revision so that you can be prepared for exams. It doesn't matter if it's June exams or December exams. This is perfect for you. This is suitable. I'm taking these question papers from the Department of Education, so you can check the website and if you want these question papers and see the questions. Okay, and you can also get the memos, the memorandums from the website. However, here in this video, we are going to be explaining how to answer these questions. Here are the questions that we'll be answering in this video, and this is the circuit that we'll be analyzing. As I'm going through this, and as I will be going through this video or this circuit, I will assume that you do not understand anything about circuits. So I won't just assume that you already have every information. I will just assume that you have little information about electric circuits. Okay, let's do the analysis. We're given question 11 and it is said that we are to consider the diagram below. And remember, we said in the previous videos when I was teaching you electric circuits on how to answer electric circuits, I said that current starts from the positive terminal of the battery. So the longer terminal, meaning this terminal, is called the positive terminal of the battery. And this shorter terminal is the negative terminal. These are the negative terminals, and these are the positive terminals of the battery. So all of these three cells, this is a cell and this is a cell with a negative and positive, a cell with a negative and a positive terminal, and this is a cell. So together they form a battery. I'm assuming you already know that if you're doing grade 10 and grade 11 and grade 12, because electric circuits starts in junior and grade 9 you already get a foundation of electric circuits, and also in grade 8 you do get a foundation of electric circuits. However, I'm not going to assume that you know anything, so I'll just assume you have the basics. Okay, now let's analyze. So it means that conventional current will start flowing from the positive terminal of the battery. Remember, we said conventional current starts from the positive terminal of the battery. If you don't know that, watch my previous videos. There are videos of electric circuits in the series. Search through the playlist and find the video and watch it. So current flows from the positive terminal and it goes through this ammeter A1. So this is an ammeter. This one is an ammeter. An ammeter, remember, is an instrument that is used to measure current of the circuit. So this ammeter will measure how much current is passing through it, how much current passes through it. So, and then the current will pass through this resistor. As it passes through this resistor, nothing changes. It remains the same. Remember, resistors that are in series, if we have resistors that are in series, to be in series, they are in this format. So we have R1, R2, R3. If they are in this format, we say they are in series. So the current is the same at this point. and it's also the same as this point, and also the same at this point. So it means the current for this 8 ohm resistor is the same as the current that is read here by the ammeter. Why? Because 8 ohm resistor is in series in the circuit. I hope that part is making sense. Okay, let's try to clear up, try to keep our circuit clean. Okay, so we were saying that the current will go through this resistor, and at this point it will start to split. If you think of current as water moving through a pipe, and the battery being a tank. If we assume that this is a tank of water, and water flows like this, it flows through this pipe and gets to this point, then the pipe branches out, or it splits. Some of the water will flow here, meaning some of the current will flow through A2 and 8 ohm resistor, and another current, meaning another water, will pass through this 8 ohm resistor and A3, and then they will combine at this point again. The water from A2 and the water from A3 combines at this point, meaning the current at A2 and the current from A3 combines at this point, and it joins, meaning it becomes the same current that got in on this side. I hope it makes sense. Let's try to clear this. We always try to keep the circuit clean. Okay, so I hope that part is very clear. This whole thing happens if and only if the circuit is closed. If the circuit is closed, this is when it happens. If this circuit is not closed, in other words, it's open, there won't be any current in the circuit. So no current in the circuit, no current in the circuit. If the switch is open, meaning we have this is an open circuit. It means the switch is open. There can never be a current flowing around the circuit, because there is no path for electrons or for charges to go through. I hope it makes sense. When the switch is open, no current, meaning no flow of water. Water cannot flow from this side to that side. I hope it makes sense. So there's no current. If we were to look at this ammeter and see, this ammeter, and see what value we will see 0 amps. Current is measured in amps. I'm assuming that you watched my previous videos, so you understand current is measured in amps. So there will be 0 amps in A1. Why? Because the switch is open. There's no flow of current. It's as if the room is dark. It's as if there's no flow of electricity. I hope it makes sense. Um, let's not waste time and go to the questions. Now I think we understand that what happens here. They say switch S is open. In other words, there's no current flowing. Switch S is open. No current is flowing in the circuit. So write down the reading on the following. In other words, what will our voltmeter 1 read? What will be the reading on voltmeter number 1 on V1? Let's go and see the circuit. Where is V1? V1 is this voltmeter that is connected across the battery. You may be wondering, what is a voltmeter? Let me remind you. I'm assuming you watch my videos, but let me remind you. A voltmeter is a device that is used in electric circuits, and this device is used to measure voltage. So we use this device called a voltmeter. This is a voltmeter. It measures voltage, and it is always connected across the component. If we want to find the voltage of this battery, then we would connect the voltmeter across, meaning in parallel to the component. But an ammeter is connected in series to the circuit. But a voltmeter is connected in parallel. Keep those in mind. Voltmeter is connected in parallel. Ammeter is connected in series. Great. Hope that part makes sense. Now we want to find the reading on V1. I said I'm explaining every concept in this video. So if you know everything about circuits, this series of videos will move very slowly for you. This is for someone who is struggling with electric circuits. So if you know, if you have a lot, like 90% of knowledge on electric circuits, this would be very slow for you. But if you would like to learn, because I'm sure there are things you didn't know about circuits, you always have something to learn. There's always room for learning. So you can watch, or you can fast forward this video, or you can find another resource to watch. Okay, otherwise I'm not going to change the pace. I will have to move slow so that if for those who do not understand circuits, they can understand. Okay, let me not waste time. We're saying ammeter is connected in series, voltmeter is connected in parallel. So in other words, if I want the voltage of 8 ohm, I would have to connect the voltmeter like this. V. That's connected in parallel to that resistor, 8 ohm resistor. Okay, we are required to find the reading in V1. What is meant? If there's no current flowing the circuit in the circuit, and we place a voltmeter across the battery, it is the same as taking a battery. Let's say you have a battery. This is a battery, and you take this device. Let's say this battery is measured 5 volts. In other words, this is a battery. This battery can supply a maximum amount of voltage that is 5 volts. It can give that amount of voltage. So if we connect a voltmeter across it, it will show a value of 5 volts because that's what it will give to the circuit if there's no current flowing. So there's no current flowing this circuit. So it means V1 will read this 24 volts that were given because there's no current flowing. So it measures the maximum amount of voltage that this battery will supply to the circuit when it is when the current is flowing. For now, we have 24 volts. But once the circuit is closed, we no longer have 24 volts because this 24 volts starts being used by these three resistors. I hope it makes sense. But because there's no current flowing in this circuit, there won't be any change in the 24 volts. So hence V1 will read 24 volts. I hope that part is clear. Let's clean up again the circuit of ours. So I'm saying V1 will read 24 volts. Why? Because there's no current that is flowing the circuit. So V1 is the amount of voltage that the battery will supply to the circuit. It means it will read an EMF. So answer for this one is 24 volts. I hope it makes sense. What will be the reading in ammeter A1? Remember, where is ammeter A1? This is the ammeter. Remember, they said the switch is open, meaning no current is flowing. There is no flow of water. Remember, we said water, we assume water is what? Is current. So there's no water, there's no flow of water around the circuit because there is a broken pipe or the switch is open. So ammeter A1 will read 0 amps, 0 amps, because there's no current that is flowing in the circuit. So let's go and answer that part. Oh, this is 224 volts. So let me clear this up. And so we said V1 is 24 volts and A1 will be 0 amps. Feel free to take a break if you feel like you're already tired at this point. Take a break, go and drink some water, and make sure you pause the video, of course, and then come back and continue because this analysis is more like teaching you at the same time. Everything that I'm going to be calculating or doing in this circuit, I will be explaining it, why I do it. Okay, so I'm assuming you already understand why we have 0 amps and 24 volts. Okay, now the switch S is closed. Note that. That is very important for us to note and understand. So If they say switch S is closed, it means now we have current that is flowing in the circuit. Now there is electricity in the circuit flowing around the circuit up until this 24 volts is finished. So it means these three resistors will consume that 24 volts because 24 volts is energy. And these three resistors of 8 ohm resistor, they are more like devices that consume energy. In other words, they eat up the energy. They use the energy. They will use that 24 volts. After that 24 volts is no longer 24, maybe it's 0 volts, then the circuit there won't be current around because there's no more energy. Okay. Hope that makes sense. Okay, let's clean it up. We say the switch S is closed. Let's close it. Let's go back to the questions. Calculate the equivalent resistance of the circuit. The equivalent resistance of the circuit means it's the total resistance of the circuit. Remember, we have one resistor that is in series, and these two resistors are in parallel to each other. What does that mean? Remember, we said that in the previous videos. If mathematically in maths, parallel lines are lines that are in this way. They are lines that can never meet. So if two resistors are parallel, it means one is on top of the other. It's in this way. They are in this way. So R1 is in parallel to R2. But R3, look at R3. This is R3. But R3 is in series to R1. You see, R3 is in series to R1. But R1 and R2 are in parallel to each other. I hope it makes perfect sense. So if we add R2, R3 and R1 together, they will form one big resistor. And this big resistor will be in parallel to R2. I hope it makes sense. I already explained this in the previous videos. Watch them. But it doesn't matter even if you don't watch them. This video will make sense. Okay. So let's go and answer the question. We are required to calculate the equivalent resistance of the circuit. So the equivalent resistance of the circuit will be the resistance of these two resistors that are in parallel, these two. So in other words, we will have to find the resistance of these two resistors. Let's go and find them, that resistance. So to find the resistance of two parallel resistors, we use this formula 1 over Rp, meaning 1 over parallel resistors. Okay, 1 over R1 plus 1 over R2. Oh, sorry. Plus 1 over R2. So this is the formula we use because we have two resistors that are in parallel. And then after we find the resistance of parallel resistors, or meaning the resistance of these two resistors, we will have to add this resistor because RT, look at this, RT depends on adding RS, meaning the resistance of the series resistor plus the resistance of the parallel two resistors. This is the total resistance of the circuit, depends on these two variables. So right now we're still calculating this RP. We're still trying to find RP. So 1 over RP is equal to 1 over 8 plus 1 over 8. Where do we get this 8? Remember, these two parallel resistors have 8 ohm resistance. Each has 8 ohm. That's the maximum, the amount of resistance that they have. So let's solve for Rp. 1 over Rp is equal to, mathematically we'll take 8. 8 goes into 8 once. 1 times 1, that's 1 plus 1 again. So it means we have 1 over Rp. I'm assuming you know this is maths. This is maths. It's no longer physics. We're just finding an unknown variable, which is Rp in this case. So I'm assuming you understand why we have this. So this will be 2 over 8. So we cross multiply. 1 times 8, that's 8, is equal to 2 Rp. Rp. Divide by 2, divide by 2. Rp, therefore, Rp would be equal to 4 ohms. In other words, these two resistors, there's two, this one and this one, when they are added together, they give us a total resistance of 4 ohms. Then this 4 ohms will be in series to this resistor. I hope that makes sense. So this means, in other words, these two resistors are added together. They are parallel. They are added together by this formula. This formula adds them together, and they become one resistor. These two become one resistor, and this one gigantic resistor becomes in series with this resistor. Okay, let me clean my circuit because it's not clean at all. Okay, but it's gonna wipe a lot of my calculations, what I'm doing. Look, okay. Okay, I hope it makes sense. Now we are required to find the total because they said we want to find the equivalent resistance of the circuit. The equivalent is the total. Rs, meaning the resistance of this resistor that is in series, meaning this one, 8, plus the 4 ohm we found for the 2 8 ohm resistors. Okay, so that's 8 ohms plus 4 ohms. The 4 ohms we got here. Remember, we divided by 2 here, and then we got Rp of, this was Rp of 4 ohms. So that means that's why we have 4 ohms here. So 4 plus 8, that gives us 12. That's 12 ohms. In other words, the total resistance of the circuit above, meaning the total resistance of these resistors, or the total resistance of the circuit, is 12 ohms. Resistance is measured in ohms. I hope that part is clear. Great. Let's not waste time. Let's move along. We are required to calculate the reading on the voltmeter V2. Let's go and see what's voltmeter V2. Remember, for what is a voltmeter? A voltmeter is a device that is used to measure voltage. So this is the device. This device will measure the voltage that is used by this resistor. It will give us the voltage that is used, meaning the energy in volts that is used by 8 ohm resistor, by this 8 ohm resistor. So this, we are required to calculate that. Remember, according to Ohm's law, if we want to find the amount of voltage that is used by this 8 ohm resistor, we know that voltage is equal to current that passes through this 8 ohm resistor times the resistance of the 8 ohm resistor. So it means we have 8 for R, but we don't have I. Where would we get I? It means we would get by finding this I, meaning the reading in A1. So now the only thing before we calculate the reading in V2, this would be the reading in V2. We need the current value, the value of I. I stands for current. Okay, let's go back to the circuit of ours. Let's go back and try to understand. Remember when I was saying that the current starts from the positive terminal. Remember, this was positive terminal. It starts from the positive terminal and then passes through this A1 ammeter, meaning ammeter number 1. So the current that is read by ammeter number 1 is the total current. Total current. So how do we find the total current? We use Ohm's law. Ohm's law is the perfect law that we can use in here. It's perfect. Very perfect. I'm cleaning all of this, assuming that you understand. So let's find the value of current of the circuit, the total current of this circuit, I total. I total. Okay, let's move. I total is equal to V total over R total. What is V total? It's 24 volts. We got it here. Let's say 24 instead of what? 24 over the total resistance. We just calculated the total resistance. Remember, the total resistance was the equivalent resistance, and we got it to be 12. It was 12 ohms. So 24 divided by 12, that's 2 amps. Current is measured in amps. Wow. So it means that this circuit has a current of 2 amps. So it means A1 should read 2 amps. So this 2 amps is the one that passes through this resistor. It passes through this one. So now for this resistor, we now have the current I, we have the resistance R. It means we can find the reading in V2 because V2 is got I times R. Remember what I just said. Okay, so that means that's gonna be 11.1.3. 11.1.3 because the one that we were calculating was 11. What was it? It was 11.1.2. Yes, for resistance, it was 11.1.2. So this is 11.1.3. So we want to find, remember, we already found the current to be 2 amps. So we want to find the V2. V2 is I that flows in, so it's I times R. I is 2, R is 8. Where do we get that? We said this current of 2 amps flows through this 8 ohm resistor. Don't forget that. Let's go back. So 2 times 8 gives us 16 volts. Then it means that 16 volts is the voltage that is read by voltmeter number 2, meaning here we will get. What does this whole thing mean? It means out of this 24 volts, 16 volts is used by this 8 ohm resistor. What? So it means the remaining resistors, the two resistors, we will use 24 minus 16 volts. Okay. So the remaining 8 volts, the remaining 8 volts is for the two resistors. Okay. That should make sense. In other words, resistors in parallel use less voltage, but the resistors in series use more voltage. Keep that in mind. It's very important. Maybe in the next video or in some question in exam, it will help you. Okay, let's not waste time. We've already wasted a lot of time by explaining or maybe oversimplifying stuff, but it's good. There's no such thing as a waste of time if someone benefits from it. Okay, so the last question, because we found V2. So what's the last question? How do we find, okay, what's the last question saying? How do the readings on ammeters A2 and A3 compare with each other? In other words, looking at these two ammeters, and these are ammeter A2, meaning ammeter number 2. This is ammeter number 2 and ammeter number 3. In other words, how will the values that will be read by these two ammeters compare to each other? Will one be greater than the other, or will they be equal, or will one be less than the other? You see that. What will happen to this? Well, let me tell you this. We said that current will split here and split into here. How does it split? It splits according to the ratio of resistance. If the resistance is the same as it is here in the circuit and for these two resistors, if the resistance is the same, meaning we have 8 ohm resistor here and we'll also have 8 ohm resistor. So it means the current that flows in here should be the same as the current that flows in here. In other words, that 2 ohm to 2 amp resistor, sorry, that 2 amps of current will split at this point. 1 amp will go through this side, when the other 1 amp will go and through this resistor, and at this point it will combine again to form the same 2 amps. Hope it makes sense. So it means the reading in A2 should be the same or should be equal to the reading in A3. Why? Because the resistance is the same. What is resistance really? It's the friction These two currents are experiencing the same amount of friction or the same amount of resistance. Resistance is friction. It's the tendency of a material to resist the flow of charges. In other words, they are resisted. The charges that pass through this one, they are resisted the same way as the charges that are passing through this one. So the current is the same. So it means the answer for this, the last question is, let's go 11.1.4. 11.1.4. So the answer for 11.1.4 would be A2 is equal to A3. Wow. Okay, that's 1 mark. We don't even have to explain, but I did explain to you. So we can say it means they are equal. The values that will be read by A2 and A3 will be the same. A2 and A3 are ammeters number 2 and ammeter number 3. Ammeters read current. Current is the same. Okay. Hope this makes sense and hope this video helped you. This is the end of the lesson. If you liked this video, leave a like, click the like button. Comment, please leave a comment. Feel free to watch the next videos and subscribe. Tell others to come and join the channel. We're having fun here, making physics fun. Tell others, share the link to this channel. Thank you. See you in the next video.